might as well start. So let's start. So actually, let's go back down to Unity. So the last thing that we were doing in the breakout thing in the last lecture was working out how to make it stop when it hit a wall. And so what we had before was, if we get rid of all of this for the moment, which can comment. So I think we had it to this stage where we could control, there we go, we can control the paddle, but we can move through walls, which is a bit of an issue. So what we want to do now is make it stop when it hits the wall. Now, the way that I was doing, that I got a bit stuck on, I worked out how to do it, is since the walls have, since the walls and the paddle both have colliders, we can make, if we set those colliders to be triggers. So I had to remake this thing from scratch because I lost whatever we made last time. So it may not be exactly identical, but I put in a wall prefab, and the walls all have box colliders, and they're all labelled as triggers. And the paddle also has a box collider and is labelled as a trigger, so that when they collide with one another, we should get trigger events happening. So what we want to do is, when we recognise that we've hit a wall, is to stop moving. The tricky thing here is that we've got to, the movement code is handled here in update, but the recognising that we've hit something happens in the event handlers on trigger end. So what we're using is these two state variables, hit left wall and hit right wall, to keep track of when we've collided with a wall. And then if we have collided with the wall, we won't allow more movement in that direction. So what I've done here is just checking, because we want to look for the left wall and right wall individually, I'm checking for them by name. So if we collide with something, if its name is the left wall, then we indicate that we've collided with left wall. If its name is right wall, then we've collided with right wall. And then up in the update, what we're saying is if the user's pressing the left key and we have not hit the left wall, then we can move left. And if the user's pressed the right key and we've not hit the right wall, then we'll move right. So now, if we save that and come over here, if we run that, okay, we move normally, we hit the wall, and we can move away. Unfortunately, there's a problem. If I move left, I stop when I hit the wall. If I move right, I can move right, but if I now press the left key, nothing happens. And the reason why nothing's happening is because when we hit the left wall, down here in on-trigger enter, we set hit left wall to true. Now, nowhere in our code do we actually set it back to false again when we're no longer hitting the wall. So it's up to, there's nothing in our code at the moment which says when you're not hitting the wall anymore, set it back to false. And so as long as we've hit the wall once, hit left wall will always be true. And as long as hit left wall is true, we can't move left. So if I move and hit the wall, now hit left wall is true. In fact, we can see it over, if we look at the paddle script, here we go. If we look at the paddle script, hit left wall is now ticked, so it's now become true. It's a bit hard to see, but you can see that. And so now if we move away from the wall, it's still ticked, and so we can't move left anymore. Now if I hit the right wall, now hit right wall is also ticked, which means that we can't move right anymore either, and so we can't move the paddle at all. And now in the editor, if we wanted to, we can untick those and allow us to move again. Oh, no, we can't. Oh, that's interesting. I thought we should be able to, but it's not letting us. So that's rather stuffed things up. So what we need to do is, when we're no longer colliding with something, we need to turn off the hit left wall or hit right wall tag. So what I've written is the same, very similar looking piece of code. Whoops, don't do that, uncomment. Very similar looking piece of code, but on the trigger exit event. So trigger exit happens when the two things are no longer colliding. And so now if you're no longer colliding with the left wall, we turn hit left wall off. And if we're no longer colliding with the right wall, we turn hit right wall off. So now if we run that, We can move until we hit the left wall, and we can move out again, and now we can move again, and that's fine. And so that does what we want. Now it's a little bit off, because if you notice, it's a bit hard to see here, but I've actually moved the paddle into the wall slightly, and it's actually stuck into the wall. And the reason that that's happening is because, in fact, if you move, depending on where you move, sometimes you stop at the edge and sometimes you stop quite embedded a fair way into the wall. The reason that's happening is because in a single frame, let me draw it on the board. In a single frame, if this is that's the wall, and the paddle is initially there, and then one frame later, in one frame it might move that far, right? And so it might move until it's embedded in the wall. Now it's only once it gets to this frame that it can recognise that it's actually a collision has occurred. And so once it's there it can stop moving, but it won't recognise it until at least a slight amount of overlap. And depending on how long our frames are and how fast our paddle is moving, it might be a considerable amount of overlap that's possible within one frame. So if we slowed the paddle down, it would move less. It wouldn't move as far per frame, and it wouldn't overlap as much. But using this method, we're always going to have some sort of overlap, because the hit will only occur once the trigger only happens once the two things are overlapping. And so if we stop after a trigger has happened, then we're stopping slightly embedded into the wall. Now, trying to solve this in what we have at the moment, it's more complicated than I want to be bothered doing. So I'm going to say that that's all right for the time being, that I'm happy to have the paddle moving into the wall slightly. Some solutions that we could do, we could, if we wanted to, we could, rather than use the triggering, we could set absolute limits on where the paddle could be. So we could say that the paddle wasn't allowed to move further left than one point or further right than another point. If we set those numbers exactly, then we could test them here and update. And by making sure that we never moved further than those limits, we could stop the paddle from ever moving into the wall. The annoying thing about that would be that then the wall and the numbers in the wall would be independent, so that if we moved the wall, we'd also have to go and change the numbers in that code. Or we could actually calculate those numbers based on the positions of the walls and stuff, but that starts to get messy. And I mean, so if we wanted to do this perfectly, we'd probably calculate the limits based on the positions of the wall and then put those limits directly into this code to make sure it never quite collided. Another option could even be to make an invisible, second invisible wall slightly further out. That registered collisions, but we couldn't actually see it on the screen. And then when we collided with the invisible wall, we could stop. And then the invisible wall would be not far enough out that we'd never go past the invisible wall. It's possible. Still fixing that, making that right would be a bit tricky. So we're going to use a rough and ready approach for the moment. But if we were going to polish this up to be a good game, we'd have to find some better solution to that problem. But let's not worry about that for now. Okay, so we have our paddle moving, which was our first thing that we wanted to prototype. The second thing, we noticed that the ball should be actually moving with the paddle when we start the game. If we won't go back to our storyboards, but our storyboard said that initially we're holding onto the ball. So it's very easy to do that. All we need to do is just take the ball in the hierarchy and attach it to the paddle. And now the ball will actually move with the paddle. Now when we want to serve the ball, essentially, we can detach the ball from the paddle and have it moving independently. So we can start with the ball connected like this, and then later on we can undo it. So the next thing we want to do is to start the ball's movement. So let's find some way of doing that. So first of all, let's have a way of releasing the ball. So if we press space, if get key base, and I think we're looking for get key down, because this is only when we press it down rather than when we're holding it down. Now, how are we going to release the ball? Well, we could have a... the ball has got to know whether or not it's being held onto at the moment. So we need some way of signaling to the ball that either it's currently being held onto or it isn't. Now, the easiest way to do that probably is to say, well, what is the easiest way to do that? First of all, we're going to need to know what the ball is. So we're going to need a variable to hold onto the ball. So we'll say ball is a game object. Right, so now the paddle actually knows what the ball is. And we'll assign the ball to there. So now the paddle knows about the ball. Now probably the easiest way to do this, since when the ball is held, the ball is going to be inside the paddle, and when the ball isn't held, it's going to be outside the paddle. Excuse me. The easiest way to indicate that is purely to base it on whether or not the ball is being held by the paddle. So we could say if the ball is going to be held whenever the ball's parents ball.transform.parent equals transform. Okay, so we're saying, remember, transform.parent is who is your parent object in the hierarchy. And so if the parent object of the ball is transform, which is the current object, i.e. the paddle, then the ball is currently being held onto. And so what we'll do just for the moment is, if that's the case, then we'll let go of the ball. And so we'll say to let go of the ball, we set its parent. Now we need to know when an object is not held onto by anything, we need some way of designating that, right? Now, in object, there are times when you have an object, so let's go back here. There are times like here when we have an object reference as a variable. And when we've set that to a value, well, it has a specific value in it. But we can also have the special value none here, which means there is no object in there. And so in this case, this would be the ball. There is no ball attached to there's no ball referred to in the paddle. Now in our code, the value none is actually null. Actually, I'm going to check that. We'll see what happens when I run that. That should work. Yes, okay, it seems to compile. So what we're saying here is that the ball's parent is now none. The ball has no parent, which means that the ball should move to the top of the hierarchy. Now let's just see if that works, because I'm not sure that I've got the code right. We press space. There we go. The ball has moved to the top of the hierarchy. So I did get it right. So if we zoom in down here in the hierarchy, we can see, no you can't see, but if you could see, oh, it's off the side of the screen as well. That doesn't make things any easier. Let's move this a little bit to the right. Okay, there we go. So you could see vaguely now the paddle, excuse me, there's the paddle in the hierarchy, and the ball is a child of the paddle. So, so the ball now currently moves with the paddle. But if we click on the window and press space, now it's changed. The ball is now up here in the hierarchy. It has no parent anymore. It's not connected to anything. So the ball is actually moving around on its own. And now if I come up to here and press left and right, you can see that it doesn't move. The ball doesn't move with the paddle anymore. So that's an easy way of detaching the ball from the paddle. Now we could use a flag on the ball to tell it when it's being held and when it isn't being held. But since the parent of the ball provides us that information, either it's the paddle or it's null, we'll just use that as our flag to tell us whether or not the ball is being held. And what we're going to do is create a script on the ball which makes the ball move when it isn't being held. So let's edit that script. Let's go to here. Let's call it ball move and edit. So now we say if transform.parent equals null, the ball is not being held, so move through space. Okay, so this is going to be where we make the ball move around. Now, if the transform is not null, then we don't move the ball because the ball is being held onto by something. So for as long as it's being held by the paddle, this value will be the transform of the paddle, and so it won't be null. But as soon as we release it, the value is now null. We know that the ball's not being held by anything, so we can move it around. Now, before I go into that, I want to just go on the slides about explaining some concept that I used there, or actually in the previous thing. We looked a little bit about Boolean expressions, and I said that you could, last week I talked about how you could combine Booleans to make larger expressions. And there are three operators that you use, and they're the and, or, and not operator. And if we look down at the, if I come back down to here, we said, so we used the and not. We said if we've got the left key pressed and we have not hit the left wall, then we do this. And if we've got the right key pressed and we've not hit the right wall, then we do this. So now, in general, how they work is any two Boolean values can be combined using and or, and any Boolean value can be inverted using not. So, for example, the AND operator will yield the value true if both of its inputs are true. So if you've got two values and they're both true, then true and true is true. If either one of them is false, then true and false, or false and true, or false and false, they all come out to be false. Right? So this is a way of testing if two things are true at the same time. We can say if this and that. And the AND operator allows us to combine them. And of course we can go if A and B and C and D if we have a long list of things that we want to combine. On the other way around, we have the OR operator, which says if one of two things is true, then it returns true, or if at least one of them is true, it returns true, otherwise it returns false. So if it has two trues, true or true is true, true or false is true, false or true is true, false or false is false. So we could say if A or B, then do something, which obviously will do it if A is true, or if B is true, or if both of them are true. But if they're both false, then it won't work. The not operator only takes one input, and you put the exclamation mark before the input. So not true is false, not false is true. So sometimes, like in the case that we had below, in the thing we had a value, and we wanted to test if it was not true. So we went, where's the cursor gone? There it is. So here we said, if this and not that. And so this is true if we've not hit the left wall. So we can combine these into complicated expressions. So we can say if we're pressing the space key and we're not pressing the right key, then do whatever we want to do in that situation. And we can chain them together into as long as an expression as we want. So we can say if this or that and the other, then, and not something else, then whatever. Notice there's precedence. If the not has precedence over the and, has precedence over the or. So if we've got an expression like this, not true and false, that's saying not of true is false, false and false is false. If we want to change the precedence, or we want to change the evaluation order, then we can use parentheses. So if we say not true and false, that's true and false is false, and then not false is true. Right? So it's just like doing arithmetic with plus and multiplies. But so you can think of the not as negative and the and as multiplication, as the or as addition, and it works out to be more or less the same kind of rules. So this would be, -1 times 0 is 0, whereas this is -1 times 0. Well, -1 times 0 is still 0, but never mind. But you know, if you change this to a minus sign and this to a multiplication sign, you get the same sort of precedence going. So in particular, yeah, you've got to worry about and or, getting your and ors around the right way. So if you say A and B or C, let me write that on the board. If you say A and B or C, remember that and binds more tightly than the or. So that's actually that, A and B or C. Whereas, you know, if you actually want to say A and B or C, you've got to deliberately parenthesize, is that a word? That part. My ampersands look terrible. Ampersand. So yeah, I mean, usually you won't want to make too complicated. I mean, it gets messy having really long and complicated Boolean expressions in your code. It's often easier to break up your code into several if statements rather than making long nested, long complicated Booleans. But sometimes it's necessary. When they are complicated and hard to follow, and they can get hard to follow, make sure you comment them so it's clear what you were intending on doing at least. So, yes, I think that's all I had to say about those. Yes, it is. All right. So we looked at those. We're going to get on to making the ball move. So if the ball is not being held, we want to make it move. Now, which way are we going to make it move? Okay, so the ball is going to bounce around, so we want to keep track of what direction it's moving in. Now, I'm going to make it simple. Is rather than keep track of a vector, we're going to keep track of two Booleans. Are we moving up, which is initially true, and are we moving left, which is initially true. And we'll also have a value in here for its speed because we'll probably want to tune that at some point. So let's say 1.0. So now if we're moving up, so we're going to either be moving up or otherwise we're going to be moving down. So we can say transform dot translate vector 3 dot up times speed times time dot delta time. So we move up by however much we're moving up. Now if we're not moving up, then we're moving down. We're always either moving up or down. So if we're not moving up, then we'll just change this to negative vector up. I don't think there is a vector down, so we'll just say negative vector up. Now at the same time, we're going to copy and paste that code, and we're going to use it for moving left or right. So if we're moving left, I think there is one here for vector 3 dot left, isn't there? I don't remember. Let's see what happens. It seems to like that. We'll call that right. Let's check if there's a vector 3 dot down. We might as well. Makes our code more easier to read if it's actually vector 3 dot down rather than down. No, see, I don't know why they didn't build in a down. They have all the others. Oh, it doesn't seem to be. We haven't put it on anything. Let's put it on the wall. It doesn't seem to be complaining. We'll see if it works. We could actually look at the script reference. Let's see. Vector 3. We have forward. No, it says forwards up and right, but it doesn't document the left. I don't know whether it'll work. Let's see what happens. So now, when we let go of the ball, hey, it moves up and left. Woo! Moves up and left rather slowly, and it doesn't bounce off anything because we haven't told it how to do that. But at least it works, right? So as long as it's being held, it doesn't do anything. But when we let go, it starts moving up and left. Let's increase its speed, because that's a bit boring. Let's make it about 5. It's moving a bit jerkily. It's a bit weird. Don't know why it's jerky, but anyway, we'll deal with it. Well, it seems to not be complaining about that code, so it's easier to read with up, down, left and right than with negative signs in there. So we'll leave it that way. Now we need to make the ball actually change direction when it collides with something. So what we're going to do, again, we're going to be using on trigger enter to check for collisions. On trigger enter, and we're colliding with some other thing. And we're going to say what is it that we're colliding with. This is a local variable just so that we don't have to keep using a long name. Other.game object. Because otherwise we'd have to keep talking about other.game object, and so it's easier to do it in the shorthand. Excuse me. So now we've got to work out what happens when we hit something. And if you remember from the storyboard previously, it was a little bit complicated to work out what to do when we hit something. Let's actually go back to that last week's storyboard. Where did I put it? Oh, maybe the previous. Oh, there it is, breakout. Okay, so when we collided with something, we decided there are these different cases of what to do when we collided with things. And it turned out that we could use the same rules for colliding with bricks as we would with colliding with the paddle and also colliding with the walls. So we had two cases, one of which is to check whether or not we're above or below the object, and if we are, respond appropriately, and the other was to check whether we're left or right of the object. So what we need to do is have some way of checking for an object whether we're above or below it, or whether we're left or right of it. So what we're going to do is make a script which goes on each of these, every brick and on the walls, which tells us, which has a function in it which tells us whether we're above or below the object. In fact, we could, I don't know whether, actually it might be easier to do it here. Let's do it here rather than, so function, yeah, it probably belongs here. We'll make a function for it because we're going to be reusing the same idea, and it's nice to have with its own function. It's in, is above, we're going to say, and we're going to say brick. Let's say brick. Right, and we're going to have another one. Is below, and we're going to have another one, or we're going to have two more. Is left and is right. And now what we're going to do in on-trigger enter is say if is above other what. What is our brick? So if it is above what, then, so if we're hitting it from above, then we're now going to be moving up. So presumably previously we were moving down, and now we're going to move up. Otherwise, if we weren't above it, if we is below what, then we're going to, so that we hit it from below. So let's put in here, hit from above, bounce upwards. And we say hit from below, bounce downwards. So whenever we hit something from above, we always end up moving up. Whenever we hit something from below, we always end up moving down. Now we can do the same code to decide whether or not we're moving left or right. So if we hit something from the left, hit from left, bounce, hit from left, bounce left, right? And if we hit it from the right, we bounce right. And we'll say, okay, moving left is true if we've hit it from the left, because that's the way we want to go. And moving right, moving left is false if we've hit it from the right. Okay, so now when we hit something, we've either hit it from above or below, or we've hit it from the side, right? If we've hit it from above, we end up moving up. If we hit it from below, we end up moving down. If we hit it from the side, we don't change whether we're moving up or down. So neither of these two clauses of the if will happen, and so it doesn't change moving up. And then we can completely independently decide whether or not, if we've hit it from the left, then we'll move left. If we've hit it from the right, we'll move right. And if we haven't hit it, if we've hit it directly above or below, then we won't change our moving left or right. So now, where we had before, like I said before in these slides, we had these 8 different cases, but we can actually divide those 8 different cases into 2 sections. This one for moving up, down, or not changing that, and this one for moving left or right or not changing that. And so, yeah, so what we've done is neatly changed quite a complicated question into 2 much simpler questions. So, I mean, it's a nice factorization of the code. This is also where it pays off to have done this sort of thinking through in your storyboard beforehand, rather than get to this point in the code and not know how the hell you're going to handle bouncing. If you've actually done some of the figuring of what you wanted to, how you wanted to respond, then writing the code becomes much easier. Now, we haven't actually implemented is above and is below. I've just put these names in, assuming that they're going to do what we want them to do. Now, this again is, we talked about earlier about abstraction, about how you can chunk your code. If I wanted to, I could write expressions for what it means by above and below and make this method much more complicated. But it's much easier to read like this. So by taking this idea of left or right, or above or below, and putting it into a separate function, I've again done abstraction in the way that we talked about with objects as also being kind of abstraction. I've taken a chunk of reusable code and given it its own name. And it doesn't matter to the computer that I've done that, but it makes it a hell of a lot more readable to a human being. You can look at that code and it's pretty clear what it's doing. Whereas if I had to do all the math within that piece of code in order to work out whether you're above or below, it would be much more complicated. So we use functions in order to group pieces of common code together to make our code more readable. We should strive to keep our functions fairly short and easy to read, and make them, if there are several steps involved, make those steps into smaller functions. So now we have to go back and implement these. We have to work out whether or not the ball is above the given brick. Now, the way of working out whether the ball is above or below a brick, well, how would we do that? So the easiest way to do that, actually the easiest way to do that is thinking, where did I put my piece of chalk? Is there a thing to rub the board with? Ah, there it is, thank you. This one. So this is one of those places where if we wanted to, so a brick is, its center is its midpoint, so its position is its midpoint. And if we wanted to work out for another point whether it's above or below, we could take this point and compare it. So this is, say, px, py, and this is qx, qy. And we could compare those two values in order to work out, we have to compare the two y values essentially to work out whether or not they are different. It makes it a bit messy having to refer to this one as qx, qy, and you'd have to take the difference and whatnot. The nice thing in, that Unity provides us is that we can convert, if we convert this into the local coordinate system of the brick, then this point automatically becomes 0, 0, and this point then becomes some point below the brick. So it gives us an easy way of so this would be negative something, and it would be underneath the brick. So we convert it into the brick's local coordinate space. It basically gives us an easy way of thinking about the position of that point relative to the brick. because we don't care where the brick is, all we care about is the relative positions of the ball and the brick. So, so rather than treat them in world coordinates all the time, which means that our code is going to get messy because we have to do a bunch of you know, relative comparisons of things. If we convert them into the local coordinates of the brick, then above or below is much simpler. So let me show you what I mean. If we take var p equals brick dot transform. Now I can never remember the right code for this. Let's go to transform. Transform has a method on it which transform point. Okay, so we want inverse transform point. Transforms position from world space to local space. So we say inverse transform point. And the point that we want to transform is the ball's position, which is our current transform dot position. So we're taking the world's coordinates of the ball, which is this, and converting them into the local coordinates of the brick. And so now that gives us a point which is referred to from this location. Now it's above. Okay, so if the point is above the brick, if okay, so actually I have to introduce something that I haven't told you about before. Okay, we'll do that. Okay, so we say anyway. Let's not do that. Let's do p dot y. So the y position of that point is now above is the positive y-axis. So p dot y is greater than, and the question is how far up do we need in order to be above the brick? So we want to be above the brick. We want to say that we're above that line, right? And that line is this distance up, and that distance is half the height of the brick, which is half of the, whoa, board's moving again, half the y scale of the brick. So this is the y scale of the brick. This is the x scale of the brick. That's already encoded in the bricks transform. So this distance from here to here is half of that distance, right? So so that's half the height of the brick, and when we're looking below, we're going to see if it's half the height of the brick. So any point. So we're going to say if p dot y. Actually, let's do it this way. If p dot y is greater than brick dot transform dot. Now I've got to remember what this is. It's called local scale. For some reason or other, it's called local scale over 2. Okay. Now the question is, what do we want to do if that's true? Now what you've seen before is having functions like this which return values. And so we're expecting this to return either true or false, right? But what I haven't shown you before is actually how to write a function which does return a value. So how you do that is you actually say return true. So now that function will return the value true if that's the case. Now there's a bit of a problem here in that it should return something else here. So otherwise return false. So if y isn't above the brick, then we'll return false. And so now the value, this function, so most functions don't return a value. So if we look for example at update doesn't have a return in it, so it never gives a value. So you can't call this as a function and expect to get a value back out of it. But we can make functions that do return values, and by doing that, we just say return value. When we get to the return statement, the function immediately exits and it comes back to whatever we're doing. So if we did something like if we put some more code down here, if we put more code down here at the bottom of the function, this code would never get executed, because either one of two of these parts of the if statement is going to execute. When return true exits, it goes back to the calling function. When return true is executed, it'll exit. When return false is executed, it'll exit. So it'll never get to this code at the bottom of the thing. So we can, so it's always important that you never write any code after your function is returned. And let's see what happens here. Most compilers will actually complain. Let's see, x equals 1. Let's just put some code in there. Does it give us any warning? Void cannot be used in a Boolean. Oh, okay. Whoops, I forgot about something. Yes. Oh, that's right. That's okay. That's just complaining about something. So most compilers, this compiler isn't smart enough to do it. Most compilers will actually complain if you write code like that. In fact, let's see, if I put that there, will it complain? No, it still won't complain. It's just not smart enough to recognize. Most compilers would complain there that was unreachable code. That there's no way of actually getting to this point, so that code is probably wrong. In this case, it doesn't matter. So we can now take that same code and put that in each of these, except that this time, so if we want to be below the brick, then we're going to be less than negative half the size. And if we're to the left of the brick, then our x position is going to be less than negative, because right is positive, left is negative. Oh, whoops, I've left something out here. That should be local scale dot x. That should be local scale dot y. Right? Because the local scale is a vector, so x, y, z. Okay. And let's copy that into here. And if that's greater than, then return true, false. Okay. So what we've said, local scale is the size of the brick. So the y is the height and the x is the width. If our position of the ball in the local coordinates of the brick is greater than half the brick height, then we're above the brick. If our local coordinates is less than negative half the brick height, so if this is 0, less than negative half brick height means we're below the brick. Same true for left and right. If we're less than negative half the width, then we're over here, and if it's greater than half the width, positive half the width, then we're over here on the right. So this should give us what we want. Let's see whether that works. I don't know whether this will work. I'm just guessing. Oh, okay. There's an unknown identifier P, because when I copied and pasted, I didn't copy and paste the whole code. Let me just do that. Paste that in there. This is what you get when you copy and paste code. Let's see whether this works. Oh, and it doesn't work. And why doesn't it work? That's a good question. Let's see. Ball. It's got a trigger on it. Okay, what have I done wrong? Let's see. Let's put some debug code in here. First easiest thing to debug is to print what.name. So when we collide with something, we should actually print its name. Okay, it's not registering that collision. Why is it not registering that collision? Because I always love it when things don't work. So the collisions aren't occurring. That's weird. Okay, I know what's wrong. I know what's wrong. We forgot to add a rigid body to the ball. Things only collide when they have a rigid body involved. So there we go. Add a rigid body to the ball and make it kinematic. Right. So now, hopefully, hey, Hey, all right, it works. Let's see if we can actually play the game properly. Yeah, okay, that's cool, and it works. Oh, so it hit it on the, when we hit it on the corner, let's see if I can do this. Nope, no, not quite. Nope. Should be able to just hit it on the corner of the paddle. Yep, hit it on the corner of the brick. It's pretty good. Yeah. Yeah, so when it's hitting on the corner, it's not working on the, oh dear, and I'm lost. Okay, so what our code is doing what we want, right? When we hit something, it bounces off in the appropriate fashion. We can even probably hit the, anyway, I won't keep doing that, but it seems to work. So the next thing, how are we going for time? We've got 5 minutes left. That's enough time to make balls start, to make the bricks start disappearing. So this is working. That's good. Let's make some code now to make the bricks disappear. So create a new script. Brick hit script. Okay, now the bricks. Okay, so brick hit. We don't need an update thing in here, so we can say handle. Let's give it a comment. Handle. So make bricks disappear when hit. And all we need to do is say on trigger enter other, and we'll say what equals other dot game object, in order, because the other is usually a collider, which is not what we want. And then we'll say if what dot name, if I can type, equals, oops, equals, remember to use double equals. If we've been hit by the ball, then we just destroy game object. This should be easy. Let's write that and stick that on the brick. Now we can stick that on our brick prefab, so all of our bricks will inherit that. No, we can't stick it on the brick prefab. Why can't we? We grab the brick prefab, stick that script on there. Please add it. There we go, add it. Right, now when we hit a brick, hey, it disappears. Cool. And now we've got a rather convincing, and I could play this for hours. Let's see if we can get an interesting shot. No. No. So that's that easy. Yeah, right, and it's working. Oh dear, I don't know. We haven't got any way of telling when we've lost, and so the ball is actually out there in the middle of space somewhere. There it is. Still moving away because it doesn't know that it's left the bottom of the screen. In fact, what we might do is, what we'll do is we want some way of knowing when the ball has left the screen. The easiest way to do that is to add another wall down there that we can't actually see. And so let's add a wall. Let's duplicate that wall. And let's call it bottom wall. And let's just stick it down off the bottom of the screen where we can't see it. Right. Now, if we add some code to the ball, which says when the if we look at the ball move, actually, we could add some code in here saying if what dot name equals bottom wall, and then we could add some code in here, game over. Well, I won't write it for now, but you could add something in there to do it. And the nice thing about that is we don't actually have to do anything more difficult about checking the ball's gone off there. We just have to make the game over happen. Now, okay, maybe that didn't happen. What happened there? Bottom wall. That should have worked. So let's just check what happens when we collide with the bottom wall. It goes through the bottom wall. Why is it not colliding with the bottom wall? I don't know. That's weird. I did actually collide with the bottom wall. It just didn't bounce off it. I don't know why it's not. Anyway, not relevant. Not important right now. We'll solve that later. Okay, so we're about out of time, but we've got a nice working game, so that's a nice, nice achievement for today. I think in the next lecture I'll summarize what I said about returning function values, and we'll write, and I'll show you about how to start keeping score for your game. Hey, it's fun. And I'll just sit here and play the game, and you can do whatever you want. All right. Thank you very much. See you all later.